Hi, in this video we're going to take a look at how to find the zeros of a function and their multiplicity if they have any, and whether or not the graph crosses or touches the x-axis at that multiplicity. That will be for number 12. Number 14, we're just going to solve for the complex roots algebraically, and both of these will be done algebraically, which means simply without a calculator. Alright, let's start with question number 12. Now number 12 is already in factored form, so when it's already in factored form you really have it made. All you have to do is set each of these factors equal to 0. So I'm going to start with the x squared. That's one of my factors. If I set it equal to 0 and take the square root of 0, which is kind of silly, but you can, you're going to get a factor of 0. Now see this 2 right here? It happened twice. So its multiplicity is 2. And we talked about in class that if it's an even multiplicity, then it only touches the x-axis. It doesn't cross over it. It just comes down like a parabola, touches it like this. Okay? And let's take a look at our second factor, which is x plus 1. And we're going to set it equal to 0. And when we solve for x, we get negative 1. And we can see that that occurred twice. We see that 2 right there. So it also has a multiplicity of 2. I'm going to just point an arrow to that, which means that it also just touches the graph, because if it has an even multiplicity again, it's going to just touch the graph. The final 0 is 2x plus 3. Notice it has no multiplicity. So I don't need to answer the question of whether or not it touches or crosses. 2x plus 3 equals 0. And so now when I subtract 3 from both sides, I get negative 3. And when I divide by 2, that gives me my final 0 at negative 3 halves, or negative 1.5. So that's how you would do that question. Let's take a look at 14. 14 is not always quite so easy. It says solve for the complex roots, which, you know, for some people that's Chinese. Complex roots just simply mean the zeros of the function, but sometimes those zeros can be imaginary numbers. In other words, the graph may have multiple zeros, but they may not show up on the x-axis. So you can determine the number of zeros by the highest degree of the equation. So there's going to be 3. We just don't know if they're all going to hit the x-axis. So the first thing we're going to do is we're going to generate a list. No, this one doesn't require us to generate a list. Sorry about that. We're going to look at it and see that it can be factored. See the GCF? The GCF is x. Again, this is in standard form. Anytime you're looking for zeros, you've got to first write it in factored form. And the first thing I saw was a GCF of x. Now this is not a once and done, because when I have this trinomial, we should recognize that as a trinomial that possibly could be factored into 2 binomials, and that's going to be determined by looking at factors of negative 6. That'll add up to the 1. Oops, that shouldn't be a squared right there. Sorry about that. So those factors will be 2 and 3. And this will be a positive 3 and a negative 2. Let's test that out. 3 times negative 2 is negative 6. Check. 3 plus negative 2 is 1. And that's what we're looking for, is that combination. It's kind of like putting together a little mini puzzle. So what I can do now is take those factors and throw them into parentheses. And now, again, you've got it in factored form. So from here, you can find your zeros. This first one is a 0. We're going to set it equal to 0. People kind of get freaked out by that one because it doesn't have a parenthesis or a number, but you know, the zero product property says if you multiply 3 terms together and the answer is 0, one of the numbers has to be 0. So since x is a term in and of itself, then it can be equal to 0. If you set this part equal to 0, then x is equal to 2. Check it out. When you plug 2 in there, you get 2 minus 2, which is 0. 0 times anything is 0. And when you solve for the 0 for this factor, you get x equals negative 3. So these were all pretty easy to do. They didn't have to use the quadratic formula or anything. So that would be the answer to that question. And that concludes this video.